Hello my dear warriors, welcome aboard to the next session of your Eamcet. Hello Sri Priya, hello Nikhil, hello Barutha, hello Ramu, welcome, nice to see you guys. Make sure you mark your attendance, let me know guys you are here in the chat box for the next killer super duper Eamcet session. And today's Eamcet session is none other than current electricity with lots and lots of theory pointers, formulas, the revision and as well as the problems along with PYQs. So it's a perfect one shot for all the students who want to prepare for this examination, and that to this major chapter, big heavyweight chapter of current electricity. If you are a JEE or some other engineering aspirant, you can still watch it. Obviously, it's not like the chapter of current electricity is going to change for the examinations, but yes, more specific towards Eamcet, lots of PYQs of Eamcet for both Telangana as well as the Andhra Pradesh students. So guys, those of you who do not know me, my name is Shreyas. I hope you guys are doing great, and I'm the physics master teacher out here teaching you kids physics. When I did my JEE, I almost got full marks in my physics examination, and here I am nurturing kids, mentoring students, and I'm so glad and really proud that so many of my kids have got really amazing ranks and gone abroad, gone to the best companies, are doing research and are very well placed and doing well in life. So hope to see you guys too in the next few years in the best of the best positions, guys. Hello Khaja, hello Shrutika, hello Franklin, hi Benedict, nice to see you guys. Hello Nikhil, Sai, hello everyone. Thank you for all the lovely hearts, and I would be really happy if you guys smash the like button and also subscribe to the channel. Means a lot, and I'm so glad that we have already reached 150k subscribers on the channel recently. So I hope in the days to come, not only we grow in just the subscribers, but also many students come and get awareness of all the competitive examinations and prepare with the best of the teachers, that too in English medium, and that too for free on YouTube. So guys, that's what our motto is, and make sure that you stay tuned by hitting the subscribe button so that you do not miss any of the classes, be it for Eamcet, be it for BitSat, be it for MIT, be it for IIT, be it for Triple IT, guys. Everything you will find it over here, and when time comes, I will give you the right updates. We don't create rumors, you know that fact. Nice to see you guys. So I hope you guys are all ready to start the session. So we want Eamcet bank material. All right, let me think about it. First live class, Gunal, you should definitely check out the previous playlist also and the previous videos on this channel for other subjects also and my topics as well. Sir, could you please explain 75 and 25 pattern in that Eamcet examination? Ajay, why don't you do one thing, just leave a comment after the session is over. I'll definitely reply to your comment, Bachchan. Thank you for putting it up. I'll definitely put it up. Thank you, Venkata Babu. Love you too, guys. Love you too. Hello, Hari. Hi, Just Manoj. Hi, Trust. Human. Wow, nice names, guys. Hi, Acing. Good evening, guys. So let's begin with the class. So let me tell you, I'm going to tell you all the important things related to current electricity, and then you will be getting the printed notes in the Telegram channel, and we will be solving problems immediately. Okay, so gear up, guys. I hope you guys are all ready for this, and I'm hoping that you have smashed the like button already. So starting with the first part, and that is basically how current is calculated in any conductor in which charges move. See, when charges move through a conductor, obviously they will move through a conductor, no, not through an insulator. So when charges move through a conductor, the flow of the charges, how quickly they move, that amount of charge flowing per unit time is called as the current. So you will see that current is nothing but charge by time. What is the unit of current, guys? Everybody knows. What is the unit of current? Everybody knows, right? It is nothing but coulombs per second, which is 1 ampere. So 1 ampere of current is 1 coulomb upon 1 second. Now this is okay if it is average current, but if it is instantaneous current, then you use dq by dt. This is more specifically used for instantaneous current. So say for example something like this. The charge which is going through a cross section happens to be t cube minus 2t plus 7 coulombs. So find the current as a function of time. So if I want to find the value of the current, here is what I'm going to do. Current will be dq by dt. So it will be the derivative of this function, like t cube minus 2t plus 7. Now what is the derivative of t cube, guys? It is 3t square. Derivative of 2t is 2 and 7 is a constant, so 0. So I will get the current as just 3t square minus 2 amperes. So this is how you can find current from the charge. Right, guys? Everybody? Yes, Balu, you'll be getting all this material on the Telegram channel, and whatever extra material I want to share, I'll definitely share it on the Telegram channel. Thank you, Aparna, Apu, thank you so much. Means a lot, bacha. Exactly, Sri Priya Buddhiraju. So this is what current stands for. Now, also something to keep in mind, that whenever you have a conductor, okay, and you see that the charges will move, it is usually the negative charges which move. So the negative charges actually move here. So this is how the motion of the charge carriers is. The motion of the charge carriers is, but the direction of the current is always in the motion of the positive charges. But there is no positive charge which is moving. So wherever the negative charge moves, exactly opposite to that, so that's where the current is going to be, right? Also, one interesting question which I have seen in many competitive exams is this. Imagine that we have a conductor, and it is found that the positive charges in it are moving this way. So this is the direction of the motion of the positive charges. Similarly, the negative charges move exactly opposite way. So this is the motion of the negative charges. Equal charges move both sides, opposite signs, but okay, equal in number in the same time. So what do you think is the net current? Is it going to be right side, or is it going to be left side, or is it going to be 0? Put up the answer in the chat box, guys. Yes, Learn by Tamil, even JEE students, IIT JEE students can watch it, bacha. Definitely, Joel, please watch it, in fact. Okay, how to join the Telegram group? Rajesh Chari, in the description box only you will see it, bacha. Come on, meanwhile everybody else answer this. I'll just show you where is the Telegram channel link. So when you're watching this video, right, just go to show more, you will see join the Vedantu JEE English Telegram channel. Just click on this, it will open up, and if you have installed the Telegram app, you will be able to join it very quickly. I hope this is very clear. Okay, so 0 says Deepa. I have a feeling 0 is not the right answer, Ajay, as well. No, hello, best motivation. Current will flow, but you know where it will flow? It will be towards the right side. Now you will be thinking, what nonsense, I thought it will cancel out. Think carefully, because negative charges are moving here. Due to the negative charges, the current because of that will be this side. This is current due to the negative charges. Because the positive charges are moving towards the right side, because of that also the current will be towards the right side. Both of them will add together to give you a total current this side. So this is the total current. This is nothing but your total current. Does it make sense, my warriors? Does it make sense, my dear students? Okay, negative charge going here means as good as saying positive charge is going that way. So the current is going like that. Positive charge is already going that side. So because of that, current will already go that side. Both will add, they will not cancel. That's the catch. Okay, I hope, Deepa, this is clear. If both positive and negative went together, then the current will be 0, because then whatever positive charge has gone, that much negative charge has gone, net charge flow is 0. Net charge is 0. Okay, JEE 2024, why do I prefer writing rather than using the slide? I feel that when you put up everything on the slide, the student's attention gets diverted to everything on the slide. Number 2, you get the real feel when the teacher writes it. I have obviously some basic things which I don't like to waste time on. Those are irrelevant. Even if I write it, it does not make sense. So these things obviously needs to be printed, but there are few things which you grasp slowly when you see it step by step. So I like to put in that extra effort so that students understand. That's the reason why I write it on the board. Okay, I hope this is clear. Just Manoj, watch my video on how to clear backlogs. I have just made a video few days back. It's just there. Okay, great. I hope this is clear. All right, funny videos definitely, bacha. Next important thing that you should know is about current density. There is current density. What is current density? What is the meaning of density? It is something per unit something. So current's density means how closely the current is packed inside. So just imagine you have a conductor like this. You have a conductor like this, and you have another conductor which is little bit smaller. Now just imagine there is some current which is flowing through this. There is some current which is also flowing through this. Here it is closely packed, here it is widely packed. Here it is dense, here it is not so dense. Here this has more current density. More current density. This has normal or reasonable amount of current density as compared to this has more current density. And this current density is how much current is there per unit area. How much current is there per unit area? So you can see the dimensions or units of this will be basically amperes per meter square. Amperes, which is there per meter square. It is a vector quantity. So whichever is the direction of the current, exactly in the same direction you should show the current density. It is a vector quantity. It is a vector in the direction of the current. In the direction of the current. Also keep one more thing in mind. Current density is I by A. Current by area is current density. But you know what? Current can be also written down as, by taking that area on the other side. By taking the area on the other side, guess what? You can also write. So if you don't want this D, it's okay. Sometimes this D can be misleading, thinking that it is elemental and all that. So I can just put it as current by S, or which is basically area. This S stands for just the area. This is also okay, guys. So if you rearrange this, it will become I, which is nothing but the current, will be equal to, guess what? It will be equal to J vector dot S vector. J vector dot S vector. This is also a very important formula. Remember, there is dot product over here. What is S vector? S vector means the area vector. You have this area, the normal drawn to it is nothing but called as the area vector, which you would have seen in Gauss's law also, in Gauss's law or magnetic flux also. I hope this is clear, guys. Very good. Yes. All right. Rate of flow of electrons per unit area? No. It is not the number of electrons, it's the charge flowing per unit area. So what you are saying, right, JEE 2024, let me tell you what you are talking about is basically this one. This current in general, which is charge per unit time, okay, this current I can also write it as total number of charges into each charge will be E divided by the time. So this also current can be written down as this formula. So number of charges into each charge, E is 1.6 10 to the power minus 19, okay, upon the time taken for it. So this is an alternate way of writing the same equation. I hope this is fine. So sometimes they might tell you that the current density is, let's say for example 5 amperes per meter square, and the area vector is, let's say, 2 meter square, and the area vector makes an angle with the current density which is equal to 60 degrees. Then what is the current flowing through it? So then what I will do is, current is nothing but JA cos theta, because that's what J dot S is, or the dot product's expansion is, A vector into B vector into cosine of the angle between them. So J is nothing but 5, area vector is nothing but 2, it will be cos 60 over here. Cos 60 is nothing but half, so 2 cancels and I'll be left with 5 amperes. So this is how you can do the calculations when current is asked, when density and area vectors are given to you. Very good. Moving on ahead to the next part, and that is basically drift speed and all these other things like relaxation time and what is this drift velocity and all of this. So imagine that you have a conductor. Imagine you have a conductor and you see that these charge carriers, which are nothing but negative, they start moving with some speed, and obviously because of that the current will be in this particular direction. The current flows here because of that's the correct conventional direction of the current, but the actual charges will move towards the left side, okay, because it is negative. The speed with which, on an average, the speed with which they move is called as the drift velocity. This is called as your drift velocity, Vd. It's the average speed with which the molecules, or the charge carriers move, which is the electrons. And there is a beautiful formula for that. I is equal to NVIDIA. If you don't like this formula, it's perfectly fine. I'll tell you, there is a better way of remembering this. And the better way of remembering this is NVIDIA. You would have heard of this graphics card company, like Intel is there, Microsoft is there, like that. Have you heard of the company called as NVIDIA? NVD, yeah, NVIDIA. So that's it. That's an easy way of remembering it. Now, if you are wondering what is this N is number of the carriers per unit volume. So you can see over here, in this volume, there are some electrons which are the charge carriers. There are some electrons which are the charge carriers. So this N stands for number of the charge carriers or the charges per unit volume. That is what it stands for. What is the role of the angle in the current? Just imagine it like this. For the previous question, I'll come to that. Imagine this problem to be in this particular manner, where you have the area vector like this, but the current is going like this. It's something like this. It's a cutout in a very weird manner. So that's why the area vector makes certain angle. So that's the significance of it. Okay, I hope that makes sense. All right. So here, I hope you guys understood how to remember this formula. Current is known, drift speed can be calculated, N will be given to you, and E is standard, A is area. Now, also you have this another formula which is lambda by T. This T stands for your relaxation time. Meaning when these electrons move, they don't simply move with the constant speed, they keep colliding with each other. Tuck, 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 they will keep colliding here and there and here and there. Agree? Yes or no? Just like you have seen in a railway station. When you go in a railway station and you want to go from one side to the other side, you are hitting this person, you are hitting that person, you are hitting this person, you keep hitting and then you slowly move ahead. Same way, the electrons also keep colliding with each other. So that tau over here stands for that relaxation time. And what is this lambda? This is the average distance. This is the average distance between the collisions. Average distance between the collisions. So from one collision to the next collision, one collision to the next collision. So that gives you the drift speed. So from here to here I travel, okay, average lambda distance in a time of tau. So distance by time will give me the speed. So how much distance do I travel from one collision to the next collision upon the time taken is going to give me the average speed. I hope this is clear. Yes, Mr. Silent, isn't this formulas chapter wise? Isn't it? It's exactly the same thing, Mr. Silent, don't spam. Okay, yes. And then you can also have the other formulas. Generally, the questions on this are very rare, but I'm giving this to you in case they ask you. Vd is equal to half E by m into tau. What is E? Charge of the electron. What is m? Mass of the electron. What is tau? Relaxation time. What is capital E, guys? Come on, put it up in the chat box. What is capital E, guys? Come on, put it up in the chat box. This E stands for nothing but, what does this E stand for? That stands for nothing but the electric field. This is electric. This is nothing but electric field. Without electric field, why will the charges move? Without field, there will be no motion of charges. Understand, only because of the field there is force. Because of the force, the charges move. Without, like somebody pushes you, only then you study, no? Same way, electric field pushes the charges to move. Yeah, I know you guys are thinking, sir, how did you show field here? Shouldn't the field be that side? Think carefully, you think. Why did I show the field here and why not there? It's a negative charge. So if the field acts here, okay, if the field acts over here, think on the negative charge, the force will be on that side. The force on the negative charge will be there. That's why the charges will go there, but the current will go this side. That's how it is. Great. Next comes Ohm's law. Okay. Next comes Ohm's law. Now what is this Ohm's law? Ohm's law, everybody knows that whenever somebody plots the graph of voltage with respect to current, that graph usually should be a straight line where voltage is proportional to current, and then that constant of proportionality is called as resistance. That's standard Ohm's law. Such a device is called as a ohmic device. Ohmic device, it follows Ohm's law, but there are a lot of devices which do not follow Ohm's law. They could be like this, or maybe they are just like this. So these are basically non-ohmic devices. Non-ohmic devices, like in semiconductors chapter you will study that many devices you will see voltage is not proportional to current, but usually whatever devices we study like resistors, wires, switches, bulbs, etc., those things you will see Ohm's law is valid and that voltage by current is going to be the resistance. Now the best part over here is that you can rewrite this same equation in a slightly different manner. And what is that slightly different manner? Observe. See, instead of voltage, you take voltage per unit length. Think carefully, what is voltage per unit length? Voltage drop per unit length. Isn't that electric field? So put electric field over here. Is that okay? Voltage per unit length is electric field. Current per unit area. Current per unit area. What is current per unit area? I just told you it is nothing but current density. So put J over here. Resistance is the resistance of the material. What will be the resistance per unit length, per unit area? That is the resistivity of that. Resistivity. It's a specific value for a given material. So instead of R, I put rho. So this stands for your resistivity. So this is how you can find the electric field inside that conductor in a very, very easy manner. Is that okay? So this is very important formula if you want to find rho, or if rho is given you want to find E, or if E is given you want to find J, some way or the other. Very commonly used formulas, guys. Alright, so let's move on to the next formula now. And the next formula is basically the power. Yep, very good. Looks like you guys are playing along with me. Keep it up, guys. I feel very happy when you post and when you play along and you type in the chat box. Not just for me, guys, but for you also. It will get inside your head. It will stay in your head. You will not forget it. It's said. So many people say this, guys, and you would have experienced it when you write, it's not just see, but you write it with your own hands. That's the time when it gets in your head. So I feel really happy that you guys are making that effort. Keep it up, guys. Okay, power. Now, whenever you pass current through a resistor, what happens? What happens is heat is lost. So there is some power loss. The power loss which occurs in the resistor is given by V into I, or I squared R, or V squared by R. Which formula out of the three will you use? The answer to that is depends on what is given in the question. So if current is given, resistance is given, you will use I squared R. If voltage and current is given, you will use VI. If voltage and resistance is given, you will use this particular formula. Okay, so keep this in mind. So this is the power loss across a resistor. Sometimes you get questions where bulbs are there, like this. For example, a bulb, is rated. A bulb is rated at 200 volts for 100 watts. If this is mentioned, you know what? You can easily find the resistance of the bulb. How? Because it is rated at 200 volts. That means if you put it in a socket where 200 volt supply comes and it produces 100 watts of energy, it requires that 100 watts of energy, it produces that light, heat, etc. of 100 watts, then I can say using the formula P is equal to V square by R. Therefore, R is equal to V square by P. So V square means 200 square divided by 100. 200 square, that's going to be 4 into 10 to the power 4 divided by 10 to the power 2. So 10 to the power 2 will cancel and I'll be left with nothing but 400 ohms. So I can find the resistance of such a bulb if needed. So for example, if I tell you there is another bulb, another bulb is there of higher wattage for the given rated voltage, then what do you think the resistance is going to be? Is it going to be more, is it going to be less, or is it going to be same? Come on, put it up in the chat box. Imagine there is one bulb which is at 100 watts, 200 volts, another bulb, it has higher wattage, maybe 150 watts, 200 watts, 700 watts, who knows? What do you think the resistance of such a bulb will be compared to this one? Will it be more than 400? Will it be less than 400? Will it be equal to 400? Think about it. Yes, Balu, we are going to do problems. First watch these. So can you read, can you watch the one shot without listening full chapter? Adi, it is not advisable, but in this given scenario, watch this complete lecture. You will get some idea. See, now you might have 5% or 2% knowledge of current electricity. From that 5%, maybe it will come to 20 or 30%. From that, start understanding what you know, what you don't know. Then watch the full lecture. Then you will understand it really well. So yes, don't expect that from one shot, it will go from 2 to 5% to directly to 90-80%. No. You will go to 30-40%, then watch the detailed classes that will push your scores or the confidence to 70-80%, and when you practice more and revise, it will go to 90 and 95% and all that. Okay, so think guys, what will happen in this case? If you notice this particular formula, resistance is V square by P. Since resistance is V square by P, as power increases, resistance will decrease. So the answer for that is the resistance will be lesser than obviously 400 ohms. Resistance will be lesser than 400 ohms. Exactly, Harini, Balaji, Srilalita, Wonder Knowledge, Excelente, Suchi Mama. No, Ajay, it's not more. No, Navrata, it's not more. Yes, Raju, it's less. Yes, very good. Sri Rama, no, it's not more. It's going to be less. Very good, Sri Priya. Excelente, Balaji, excelente. Okay, next. Resistance. Okay, so how else can you write resistance in terms of the material characteristics like this? So if you have a conductor of certain length L and area A, then the resistance of such a material, so when you write it as a resistor, the resistance of such a material is given by rho L by A. Keep this in mind, rho L by A, very crucial. Sometimes you will see that you stretch it, compress it, etc. So when it is stretched or it is compressed, what remains constant is very important. The volume remains constant. That means area into length remains constant, which is equal to capital V. That is not voltage, it is volume. So from this formula, R is equal to rho L by A. Instead of A, I can write it as volume by length. Is that fine? Instead of area, I can write it as volume divided by length in this formula over here. Length will go on the top, so resistance will become rho L square by volume. So resistance is directly proportional to the square of the length if it is just stretched or compressed, meaning that you are keeping the volume constant, because when you pull it, length might increase but area will reduce. If you compress it, length will reduce but area will increase. So that's why you will use this formula. Okay, no problem, Sujimama. We are coming to that also in a bit. Okay, I hope this is clear. Now this resistance can also change with temperature. So as temperature increases, you will see, so as temperature increases, you will see the resistance also increases, the resistivity also increases. In fact, there is a law for that, and that is exactly similar to your linear expansion, something like this. R is equal to R naught 1 plus alpha into delta T. You can also rearrange it as R minus R naught, which is the change in the resistance, is the original resistance alpha into delta T. This alpha is your coefficient of thermal resistance. Coefficient of thermal resistance that will be again given to you. This is how resistance changes with temperature, my dear students. Is that okay? Clear? Everyone with me on this? Everybody with me on this? Cool? So you have these formulas as well. So you will see that as temperature increases, the relaxation time decreases, the resistivity increases. That is another way of looking at it, because when temperature increases, molecules collide more frequently. They will collide, dishum, 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 they will collide. So the time that they get to relax reduces. So that's why you can see tau is there in the denominator, and that's why you will see resistivity will increase. When temperature increases, resistivity will increase. That is what you should know. Great. Now, I hope you are ready to solve some questions based on this. Okay. What about our values of alpha for conductors and insulators? See, alpha for basically conductors, okay, it will be on the positive side, but it is very small, 10 to the power minus 5, 10 to the power minus 6, 10 to the power minus 4. It is not like 100, 200. Okay. For insulators, Balaji, we will not talk about resistance. It has infinite resistance. So there is no conduction only. So it does not matter whether you increase the temperature or decrease the temperature, it will not conduct only. So that's why for insulators, we will not even talk about alpha. Okay. Yes. So Bharat, even a non-Eamcet student can watch it, but yes, there are a lot of Eamcet students who want Eamcet level of coaching. So the level, the pattern, the type and PYQs, everything is of Eamcet, which is almost the same as JEE mains only. You will see that. Here is the first question coming up on your screen. So Suchi Mama, internal resistance, I'll come to that when I talk about battery. Just give me a moment. Just give me a moment. Okay, I'll just come to that. So current and voltage are respectively the current and, if I and V are respectively the current and voltage in a metallic wire of resistance R, the two graphs shown, this axis is current, this axis is voltage. Maybe I think it has not got printed, so I'll just print it over here. So this is basically your current, this is basically your voltage. If these are the two graphs for current versus voltage, which of the following temperatures are more or higher, equal, less than, whatever you say? Yes, come on guys, think about it. Mr. Silent will be doing recent years PYQs in a bit, not now. I am telling you right now, it's very important you understand concepts. So whatever best PYQs I can find, I am putting it over here. Now whether to do 2015 onwards or before 2015 or 2020, I'll keep a separate session for that. Don't worry. Because we can have a problem solving session just for PYQs separately. Right now, I'm mainly focusing on the chapter concepts. So whichever question is the best, trust me on that, that will be helpful for you. So don't go into that logic, I want only recent year PYQs. That is one common mistake which many JEE students also do. They just study recent PYQs, they forget the previous old PYQs. But there are a lot of times olden PYQs have very good concepts and they suddenly come over here and then you're like, oh, I should have practiced it. The correct answer for that is option C. Option C. Thank you for all the love from Anantpur Bacha. Yes. So here is what we are going to do. Here is what we are going to do. This is current and this is voltage. Oh, by the way, I will be coming to Hyderabad very soon for 1 or 2 days. So you guys, if you want to meet me, I would be very happy. I'll be coming to Hyderabad in the during Christmas time for a day or two. So if you guys want to meet me, I'll be very happy to meet you guys. Maybe somewhere we can decide on a place. All right. So T1, T2 and current and voltage, guys. So what we can do? So what we can do is basically I can write current is nothing but voltage by resistance, right? V is equal to IR or current is V by R. So I can just rearrange this. So from this I can see that R, because this is current versus voltage graph. This is current versus voltage graph. So I can see very well over here, if I divide I with V, current with voltage, I will see this as 1 by R. Current by voltage is nothing but the slope. So slope is 1 by R. You can see T1 has more slope. If slope is higher, that means the resistance is less. If resistance is less, obviously the temperature is also less. So this guy has lower temperature. So this is lower temperature. This is lower temperature, and this is obviously higher temperature. This is higher temperature, guys. So hence the correct answer is option C. C for captain. C for capto. Vendor knowledge, yes, definitely. I'll come to Chennai also someday. So Thankraj Raj, what is electrical resistance? Resistance is basically something which basically stops something. So just like, imagine this over here. I'll just take this example. You connect a battery. What does a battery do, man? Battery, it creates high potential here and it creates low potential here. There is a potential difference created by the battery. Now, when you apply this potential difference across a conductor, what will happen? Current will flow. Current will flow, right? From high potential to low potential. A rock falls from high voltage potential to low potential energy. Same way, current also goes from high potential to low potential. How much current will flow? How many charges will go will be decided by the resistance. More the resistance, then less the current. Less the resistance, more current. It's like resistance is like a very bad road. If the road is bad, very few vehicles will go. If the road is good, like an expressway, many vehicles will go. So that's what it is. Okay. Now talking about, somebody was asking what is internal resistance. I'll talk about that as well. Okay. So guys, just focus on the problems. I'll just come to internal resistance because we are going to talk about combination of batteries in a bit. So the temperature coefficient resistivity of a material is this much. When the temperature of the material is increased by 50, the resistivity increases by this much. What is the initial resistivity of the material? Yes, Vijita Desari, you can definitely continue. Definitely you can continue. Can a North Indian student, Vishnu, I doubt bacha. I think you need some kind of certificates. Okay. So let's have a look. Let's have a look on how to solve this. I just told you resistance formula is very similar to linear expansion coefficient. Same way over here, the resistivity at some temperature will be the original resistivity, okay, into 1 plus alpha delta T, or you can write it as rho T minus rho naught is equal to rho naught into alpha into delta T. I want to find the original, the initial resistivity. That means I want to find rho naught. Rho naught will be rho T minus rho naught upon alpha into delta T. What is the top? The top numerator is a change in the resistivity. Its resistivity increases by this much. So the top is 2 into 10 to the power minus 8 divided by alpha. That's the coefficient of resistivity of the material. That's I think 4. So 4 into 10 to the power minus 4, right? Change in the temperature is 50 degrees Celsius. So put 50 over here. Now what I can do is 50 into 4, that's nothing but 200. This 2 will be there on the top. 10 to the power minus 4, 10 to the power minus 8 will cancel. It will become 10 to the power minus 4. So this will become nothing but 10 to the power minus 4 divided by 10 to the power 2. So this will become 10 to the power minus 6. Is 10 to the power minus 6 not there? Okay, no issues. I can deliberately add 2 zeros. So then I'll have to make 10 to the power minus 8, right? Because I added deliberately 2 zeros. So I have to put extra 10 to the power minus 2 over here to make it equal. So hence option C is the correct answer. No, Namrata, it is not B. Yes, Balaji, it is C. Very good, Krishna. Excellente. Excellente. Yes, temperature is directly proportional to resistance. Exactly. That is true. So that's why this formula is also making sense, because as the temperature increases, the resistivity also increases. Okay, I hope this is clear. Moving on to the next one. If this is a beautiful question, guys, this is a beautiful question. Okay, there is a side of a rectangular block 2, 3, 4. What is the ratio of maximum to minimum resistance between the parallel faces? If you solve this now, pakka guarantee you will clear 100%. You will get super duper marks. Beautiful question it is. So let me just show a cube, something like this. Not exactly a cube, sorry, cuboid. So one side is let's say 4 centimeters, then there is 3 centimeters, then there is 2 centimeters. So imagine passing the current like this. If you pass the current like this, then this will be the area. This will be the area that you will be considering because the current will come out from here. So in that case, the resistance will be rho L, L is 3, divided by area, which will be 2 into 4. 2 into 4, right? 2 into 4, which is nothing but 3 rho by 12. Now, if somebody decides, no, I want to pass the current from here so that it comes out from here, then for such a arrangement, this would be the area of cross section. So in that case, R2 will be rho, length of which it is traveling is 4, divided by area, this side into this side, 2 into 3. So it will be 2 into 3. So it will be nothing but 4 rho by 6. Correct? Similarly, look at this another option. I can also send the current from here, and then this will be the area under consideration. So in that case, R3 will be rho, length is nothing but 2, area is 3 into 4. Area is nothing but 3 into 4. So it will be 2 rho by 12. 2 rho by 12. I hope you can see that. Oh, I'm so sorry guys. By mistake, I wrote 2 4s are 12. I'm so sorry. This should have been 8. My bad. I'm so sorry. Okay. Now look at all these numbers. Look at all these numbers and tell me which is the maximum value and which is the least value. Which is the maximum value, which is the least value. Come on, tell me about it. Which is the max and which is the least. Look at the numbers. You will quickly realize here this is maximum and this is minimum. So the ratio as a whole will be least. This is the minimum value. Denominator is highest, numerator is lowest. Denominator is highest, this is lowest. Correct? Similarly, if you look over here, out of all the three, this has the smallest denominator. This is the least denominator, and this is basically the maximum numerator. So as a whole, this ratio will be maximum. This will be the maximum ratio that you can get, but that means maximum resistance. So they are asking maximum to minimum resistance. So what they are asking is basically R2 divided by R3. R2 divided by R3. Now do the math, it is not that difficult. R2 will be 4 rho by 6, 4 rho by 6, and R3 will be 2 rho by 12. So it will be nothing but 2 rho by 12. So you can see over here, rho cancels, 2 goes with 4 2 times, 6 goes with 12 2 times. So 2 2s are nothing but 4. So the correct answer to this question is option A, which is 4. Yes, it is. Very good. Beautiful. Looks like Ishwar, Sri Priya. Yes, Vijita, thank you for pointing it out. Very good, Maxwell. Aditya, silent. Balaji, very good. Suchi Mama, very good. Visaram, Namrata, Srilatya. Very good, Adi. Very good. Wonder knowledge. Looks like so many of you are going to crack it. Very good. Very good. Very good. So you just have to play with the numbers. And you have to visualize that you can pass in different ways, get different areas, and get different lengths. Next question up on your screen. There is a nichrome wire, 50 centimeter long, 1 square millimeter cross section, carries current of 4 amperes when connected to 2 volt battery. The resistivity of the nichrome wire in ohm meter is. Hello Nellore, Anjali, welcome bacha log. Nice to see all the students joining in from all the cities of Andhra and Telangana. So guys, over here what we can do is visualize a small cross section which is connected to a battery of 2 volts. So there is a battery of 2 volts connected across it, because of which there will be some current flowing through this. Current flowing is basically 4 amperes, and this wire is definitely going to have some amount of resistance, and you can easily find that resistance R, V is equal to IR, so R is equal to voltage applied by current. Voltage applied is 2 volts, current flowing is 4, so it is basically half ohm. Correct? It is half ohm. We also know one more thing. What is that another thing that we know? We know that resistance is rho L by A. And the question is find resistivity. Find resistivity means rho. So rho will be R A by L. Correct? R A by L. R I just figured out, it is half. Then you have area and length. Length of the wire is it given 50 centimeter long. So this is basically 0.5 meters. Area 1 millimeter square. 1 millimeter is 10 to the power minus 3, square of it, so raised to 2. 2 into 0.5 is 1. 2 into 0.5 is 1. This will become 10 to the power minus 6. So do I have 10 to the power minus 6? Yes. So this whole thing becomes 1 into 10 to the power minus 6 ohm meter. Exactly. Proud of you guys. Proud of you. Very good, Aditya, Balaji, Wonder Knowledge, Vijita. No, yes. Yes, 10 to the power minus 3 was the millimeter. So 10 to the power minus 6 will be millimeter square, Wonder Knowledge. Very nice, Sriram. Excellent day. Moving on to the next question. Okay, so we have Kirchhoff's laws, which is coming up. So before going to Kirchhoff's law, one more thing that I would like to tell all of you. See, when we talk about a battery, this is how a battery looks like. Everybody has seen battery or played with batteries in their life. And when you connect a bulb or something to it, so this battery acts like the supplier of the energy. It acts like the supplier, and this bulb, motor, resistor, device acts like the consumer of the energy. Now, here is the thing, guys. If the battery supplies, example, 10 volts, basically that's the EMF of the battery. Understand, across the bulb, you will not expect 10 volts EMF or voltage. In fact, across the bulb, you might get a drop of only 9 volts. Then you might be wondering, the battery is giving 10 volts voltage difference. Why is the bulb getting 9 volts? The reason for that is internally also, there is somebody who is taking some tax cut, some commission. So it's like a tax that you have to pay to get out of this, and that is basically your internal resistance. So there will be internal resistance which will consume exactly, let's say over here in this case, example, 1 volt. So that will also be a consumer. So whatever you supply, not everything is given to the outside circuit. So that is the reason why you see batteries or cells get heated up. Because within the cell itself, when the electrons flow in that fluid, in that particles between that cell, there is some resistance offered. So the resistance inside a cell, when the charges flow inside that cell, that is called as internal resistance. So you will see that an ideal battery, an ideal cell will be shown like this, but a real cell will be shown like this. A real cell will be shown like this. So understand that this is what is there inside the battery. This resistance is there inside that battery. I hope this is clear. Suchi Mama. Okay, whether to use Kirchhoff's law or not, we are not taking into account internal resistance of the cell. So Balaji, depends on the question. See the question. If internal resistance is given, take it. If it is not given, or if it is not needed, don't take it. Usually internal resistance are very small. So that's why many times it is neglected, even while taking Kirchhoff's law. But if it is mentioned, battery 5 volts, 2 ohm, then take it. Okay, I hope this is fine. Next chapter, Bhanupriya, will be ray optics. Thank you so much, Mr. Silent. Okay, hello Abhiram Vina. Alright, shall we move ahead to Kirchhoff's law? Okay, so Kirchhoff's current law is very simple. Kirchhoff's current law is very simple because it just talks about input-output. Imagine if there is a junction, some wires are being joined over here, okay, some wires are being joined over here, some current will come in, some current, let's say, comes in from here, and some current goes out from here, some current goes out from here. Whatever comes in should go out, just like equation of continuity. Which chapter did you study? Which chapter did you study, guys? Fluids, right? So whatever will come in has to go out. So that's why net current coming in will be the net current going out. This concept is completely based on, the Kirchhoff's current law is completely based on the concept of conservation of charge, because no charge can stay accumulated or nor can it be removed from that wire. It's a conservation of charge. Kirchhoff's voltage law is based on the concept of conservation of energy. Conservation of basically energy. It says that when you go across a loop, the total sum of voltage drop across the resistors plus the total sum of voltage drops or increases across the EMFs the total voltage drop basically comes out to be 0. You start at a point, see the voltage drop, see the voltage gains, and you come back to the same point, you will see the total sum will be 0, meaning something like this. Imagine there is a big complex circuit like this, okay, some circuit is there in this particular manner, okay, and you happen to go like this, okay. So let's say you have to go across this circuit, and you find that while you go from here to here, you start from this point, while you go from here to here, the voltage increases by 2, okay. Then while going from here to here, nothing happens. While you go from here to here, let's say the voltage drops by 3 volts, okay. Keep a mental count. So first it was 2, then it was -3. Then while going from here to here, nothing happened. Let's say while going from here to here, the voltage increased by 2 volts again. Going from here to here, the voltage increased by, let's say, 1 volt here. While coming back here, then I saw that voltage dropped by, let's say, 4 volts. Here nothing happened. Here it dropped by some volts. Let's say -1 volt. Now just count how much has the voltage changed in this due course. Here it increased by 2, so 4 plus 1, 5. So total increase is 5. And total decrease 3, 4 is 7, and more 1, so that becomes 8. So it decreased by basically 8. So if you add them, 5 minus 8, it becomes -3. So this does not correctly use Kirchhoff's voltage law, or this is proving that Kirchhoff's law is wrong. That means there must be one missing piece in this puzzle. So there is some place where the voltage will increase by 3 volts, maybe over here, example, maybe over here. So it increases by 3 volts. Now if you see, it will be like +8 and then -8. So the total over here will be 0 volts. That's what Kirchhoff's law is. So at some places it will increase, at some places it will decrease, and as you go across the circuit and come back, the total change is going to be 0. Now it makes sense. I hope this is clear. Now you might be also confused about, sir, which direction is positive, which direction is negative. Sir, when I go from one place to another, I don't know whether it is increasing or decreasing. So for all the students who get confused with the directions, here is the simple technique. So let's say if you are going from here to here, okay, if you are going from here to here, this is lower to higher potential, so you will consider it as +E volts. Okay, you will consider it as +E volts. If you are basically traveling from this side to this side, high voltage to low voltage, it will be considered as a drop, just like over here. When you go from low to high, it is an increase. When you go from high to low, it is a decrease. Similarly, if you talk about resistances, okay, this is the direction of the current. Here current direction does not matter. If you travel in this direction, opposite to the current, very crucial, then it is +IR, opposite to the direction of the current. And if you travel, let's say this is the resistor, this is the current flowing through it. If you travel in the direction of current, then it is -IR, that means it drops. This is what the sign convention is, and you should know that. Very, very important. How to find the potential difference? This is the logic to find potential difference, Bhanupriya. If it is a battery, now it is just E, because battery has a job, only one job, maintain potential difference, E volts. If it is 5 volts, it will be 5 or -5. It's a resistor, it will be IR. Whether it is +I or -IR depends on how you are going. If you are going in the direction of current, then -IR. You are going opposite in the direction of the current, then +IR. Is that clear? Okay, I hope this is clear. Here in battery, the direction of current does not matter. So let me show it to you this way. So the current could be anywhere. The current could be anywhere. It's just showing how you are traveling. Current could be anywhere. I do not know that. Current could be anywhere. Does not really matter. It's the direction in which you travel. In which you travel. Clear? Okay. So whether we can use Kirchhoff's law when there are electrical components like diode? Yes, you can use it even when diodes are there, even when inductors are there, even when capacitors are there. So for example, if a capacitor is there, okay, this is positive plate, this is positive plate, this is negative plate. If you travel from the negative plate to the positive plate, the voltage gain will be plus Q by C. Because Q is CV, V is Q by C. Whereas if there is a capacitor like this, this is the positive plate, this is the negative plate. You go from higher potential to the lower potential, the drop will be Q by C, negative Q by C. So it depends how you are traveling. Yep. Plus IR in the resistor. No, this is fine. This is not the direction of the travel. This is the direction of the travel. Don't look at this arrow mark, look at this dotted line. Who is that? Sri Priya. Sri Priya, I am going from here to here. Here to here. Current flows in the resistor always from high potential to low potential. So when you travel like this, you are going towards a higher potential. So it is plus IR, it is perfectly fine. And when you go in the direction of current, it is negative IR because current goes from high to low. So it's dropping. It's perfectly fine. Don't worry about it, Sri Priya. So only for this guy, it creates a problem. People get confused. Oh, always opposite. Is that okay? Very good. Great. Moving on to the next one. Resistors in series, I'm pretty sure everybody remembers. Total resistance is R1 plus R2 plus R3. What is same and what is not same? Just answer that. When resistors are in series, what is same? Current is same. And what is not same? What is not same? Voltages. So across each one, you will see that the voltages are going to be different. Hello Archana ji, welcome bacha. Hello Imran. In case of resistors in parallel, 1 by R1 plus 1 by R2 plus 1 by R3 is the 1 by R equivalent. So tell me in parallel, what is same and what is not same? In parallel circuits, the voltages are same, currents are distributed. So in parallel circuits, it's the voltage which is same and the current gets distributed as I1 plus I2, so on and so forth. Currents are distributed, correct? Perfect. Then, let's do some questions. Weightage of physics for Eamcet exam, that's standard, 40. So, have you seen my session, V. Sriram? Standard, 80, 40, 40. 80 is maths, 40 is physics, 40 is chemistry. Alright? Okay. So, N conducting wires, interesting question, this was asked previously. Same dimension but resistivities, 1, 2, 3, N, connected one after the other, that means in series. What do you think is the equivalent resistivity of the combination? Beautiful question. Beautiful question. Board's weightage is 0, bacha. There is only eligibility. There is no weightage of boards for JEE. So many of you are saying option A. I think you guys are most likely going to be wrong. Most likely, I think so. Like that, you have basically N resistors, each having resistivity. This is having resistivity 1, this is 2, this is 3, this is basically N. So the effective resistance, if I consider it as one single resistance, if each one of them had length L, 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 this is having area A like this, then the total effective resistance will also have the same area, but the length will be N times of L. Length will be N times of L, understood? Because I'm replacing this with one single resistor. The resistance of this will be rho L, L is NL divided by A. Agreed? Whereas the resistance of all these things together will be rho, which is going to be 1, rho, which is going to be 1, L, which is L divided by A, next one 2L by A plus 3L by A, like that NL by A. Now obviously all these together and this one have the same resistance, so just equate these two. just equate these two. So what will you get? Rho NL by A is equal to L by A common, and we have 1 plus 2 plus so on and so forth till NL, correct? Oh, sorry, not NL, just till N. L is taken common. So what is 1 plus 2 plus like that? If you do, it is nothing but N into N plus 1 divided by 2. Here I have L and A, and here I have rho N L divided by A. Do you see what and all is getting cancelled? Do you see what and all is getting cancelled? L L, A A, N N. So what am I left with? What am I left with? Rho is equal to N plus 1 divided by 2. That's all. N also gets cancelled. Option B. Many students make the mistake of initially marking this because they miss NL here. If you miss NL, that's it, you will get answer A. Why you have to take NL is because when you combine them as one single resistor, whatever the total length was, that same length, this guy, which is replacing these people. What is this guy doing? It is replacing all these resistors with one single resistor. So you have to take the same length. Don't take L. That is a common mistake. Understood? Common silly mistake. Many students made that mistake, got 0 marks there. Moving on to the next one. Uniform conductor resistor are cut into 20 pieces. Half of them in series, remaining half in parallel. When they both are combined in series, then what is the net effective resistance? So let's see. We have a big resistor of value R. You make a small part of it. So there are 20 pieces, if I'm not wrong. 20 pieces, yes, 20 pieces. Each piece, the resistance of each piece will be how much? Will be R by 20. Is that right? Now what have you done? You have taken 10 such pieces in series. So there are 10 such pieces, okay, in series. So this is in series. So the resistor of series will be R by 20 plus R by 20 10 times, correct? So this will be nothing but 10 into R by 20, which is basically R by 2. So that is the resistors which are connected in series. Now there are some resistors which are in parallel also. So there are some resistors which are like this in parallel. So the equivalent resistance 1 by Rp will be 1 by R by 20, 1 by R by 20, like that, I will have how many terms? 10 terms like that, 10 terms like that, correct? So this will be 10 times of R by 20, this will be 10 times of R by 20. So what will you get Rp as? Rp will be, flip it, R by 20 by 10, which is R by 200. This is R by 200. Everybody with me on this? Okay. So now what have you done? You broke 20 parts. Each part is 20. Out of those 20 parts, 10 parts are in series, 10 parts are in parallel. So the combined diagram will look like this. It's like you have 10 resistors in series like this, and then you have those 10 resistors like that in parallel. Okay, so this is how the diagram, okay, will probably look like. I hope this is clear. Everybody with me? So you broke 20 pieces, 10 pieces are here, 10 pieces are here. I know this much part is behaving like one single resistance of R by 2. This is behaving like one single resistance of how much? R by 200. So the combined equivalent, so the final equivalent, R equivalent will be, both are in series, so R by 2 plus R by 200. So use LCM, guys. So this will be, R is common and 200 is the LCM. So this will go 100 times plus this one. So this will be 101 times of R divided by 200. Is the diagram and the method and the procedure clear? See if this is option C. Yep, it is correct. Yes, Aruna, you understood this circuit diagram? Which circuit diagram? Thank you, Ramya. Did you understand this circuit diagram? Finally, What have I done, Aruna? Lilamlia? Is that clear? What I have done? I have taken 20 pieces, taken 10 pieces out of that, one after the other, tuck, 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 tuck. And the remaining 10, tuck, 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 I have put it parallel. These together, because they are in series, r by 20 plus r by 20 plus r by 20, 10 times. It will become r by 2. This is 1 by r by 20 plus 1 by r by 20 plus 1 by r by 20, 10 times. So 10 into this thing. Solve it, you get it as r by 200. Now this and this both are in series, so just add them, you will get the final answer. Which circuit diagrams? Are you talking about this circuit diagram or some in general circuit diagram? Oh, the playlist. Aruna, do one thing, leave a comment. Okay, I'll tell you where you can find it, and even for others, those who want to study this particular chapter in detail also, you can do one thing, go to playlist. I understood what you guys are saying. Okay, so it'll be little bit clear, guys. I get scared when you ask, sir, please explain circuit diagram. So it is very generic when you ask such things. So guys, look over here. This is the playlist in 12th standard physics, chemistry, maths. Click on the Pathfinder physics playlist. You can go over here and then go down. You can see over here, you can see current, electricity, all the detailed classes, current, density, drift, speed, resistance, then power series, parallel resistance, then KCL, KVL special lecture, galvanometer, ammeter, voltmeter, then all about potentiometer, one lecture, advanced question, one lecture, current, electricity, one short revision, one more lecture. So all these lectures are there for you. Okay, is that okay? Fine. Thank you. Love you too, Ajay. Thank you so much. Okay. During revision, finding it difficult to solve the questions of NLM and friction even after watching crash course video, what to do? Nanda, if you are in the crash plus, watch the detailed classes. If you are in the crash plus, if you are in the crash, then do one thing. Again, just like I showed you the playlist, watch my playlist also, which will help you in addition to the regular crash course lectures. If you're in the crash plus, you get other long-term batch lectures as well. That is the advantage, but it's okay. No problem. You can watch my classes over here. I have done backlogs. I have done one-shots. I have done detailed. So watch the detailed classes. You will perfectly understand it. Thank you, Mr. Silent. I'm so glad, guys. So guys, if you're loving these Eamcet classes, you know what you should do now. Come on. Cheppu, what are you going to do? Silent. Don't say silent. I think you should be Mr. Cheppu. You know, because you talk. Alright, so what are you going to do, guys? You are going to tell your friends. You have to tell your friends, your batchmates, your neighbors. You know? You have to tell them, come, sir is there. And sir is teaching for Eamcet, for all the Andhra and the Telangana students. Watch it. You don't have to go anywhere. Sit at home and do it. You don't have to go waste your time in some traffic or travel some other big city or travel to some coaching. Sitting here at home, you can watch my playlist. Guarantee number improvement. Exactly. Can this question also be expected in mains? Yes, definitely, Vijita Desari. If you solve what you are explaining questions, we can solve. Yes, Eamcet questions you can solve. Look at this. These are Eamcet questions. I'll be doing a previous year Eamcet series also after some time. Just give me a few days. I'll do some important topics and then we will go to PYQs, mock tests, part syllabus and all those things we are doing. Okay. So Muzakir, it is taking longer than expected for the Eamcet crash course, but as of now, I will provide full support on YouTube, whatever I can. Okay? So I am going to put in some extra effort on YouTube for you guys. Right now also, this is my 5th or 4th class for the day. So, you know, I'm going to make sure that whatever happens, I'll try my best as long as my health is going to support me to come here and take classes. Okay. So as of now, it's on YouTube, whatever we are doing. Okay, so watch these classes. I'll try to put in as many lectures as possible. You can watch the JEE playlist also. Okay, so let's go ahead. A conductor of resistance 3 ohm is stretched uniformly till its length is doubled. The wire now is bent into form an equilateral triangle. The effective resistance between any side of the triangle. Guys, whenever you stretch it, I had told you what you should do. Just some time back, look over here. Where did it go? When you stretch something, I think I had given you over here. Yes, when you stretch something, use rho L square by V. Rho L square by V formula. So let's go over here. Okay, so when you stretch, the moment you stretch, the resistance is given by rho L square by volume formula. Correct? Now what has happened is that the length has doubled 2 times. Naturally, because it is L square, So RHS will actually become 4 times. So even the LHS will become 4 times to give you the new resistance. Old was 3, 3 4s are 12 ohms. This is the new resistance. Everybody? Chapter? Very good, Ravi. Okay. How many questions from basics, Aruna? I mean, like, you should solve at least 40 to 60 questions minimum from each chapter from basics. Then you should go to average level, at least another 50, and then maybe 10 to 20 questions PYQs from each chapter at least. That's how the flow should be in these last few days. Now you form a triangle. The moment you form a triangle like this, what happens? You can think of it. Okay, this is one point, this is another point. This 12 ohms is divided into 3 parts. 1, 2, 3. So this is 4 ohms, this is 4 ohms, this is 4 ohms. So you have 3 resistors, 4 ohms, 4 ohms and 4 ohms now, and you have to find the equivalent between these two. You can clearly see that it is as if you have 2 resistors in series here and 1 resistor over here, and that is connected between these points. This is 4 ohm, this is 4 ohm, this is 4 ohm. When you simplify this circuit, it will look something like this. Okay, you will have 4 and 4 becoming 8, and this is as it is 4 ohms, correct? This is as it is 4 ohms. Now if you convert it into one single resistor, the equivalent resistance will be R1 R2 4 into 8 upon R1 plus R2, so 4 plus 8. So this will become 4 into 8 divided by 12. So this goes 3 times, so this will be 8 by 3 ohms. 8 by 3 ohms. Do we have such an answer? Option B. Very nice. Yes, Vijita. Very good, Aditya. Excellent. No, it is not A, Sri Priya. Little bit mistake you did somewhere. Just check it. Hello, Vishasri. Okay, so looks like you guys are in through some different accounts. Maybe your parents or elder brothers or sisters. No problem. The Eamcet exam, my prediction is in May, max to max June, not in July. Okay, July will be too late. Okay, beautiful question. Moving on to the next one coming up on your screen. Interesting. So here it is. The current of 2 amperes in an electrical circuit is as shown in the figure. What is the potential difference in volts between R and S? Beautiful question. So observe carefully. You will notice from the top, whatever current goes in, and from the current, whatever current goes in should be equal, because here 3 plus 7, which is 10 ohms, and here 7 plus 3, which is also 10 ohms, means that whatever current comes in of 2 amperes, it should get divided equally as 1 ampere and 1 ampere. Does that make sense? Equal division of current, because same resistance is there in both the paths. Okay, now let's assume that this particular point has a potential of V0 volts. Now because you are going in the direction of the current, which is 1 ampere, when you reach at this point, the potential of this point VR will be, this point's potential is V0. When you travel in the direction of current, it's always a drop. Remember, initial potential was V0. So as you go ahead, how much is the increase or the drop? It will be dropping because you are going in the direction of the current. So how much is the drop? It is IR. So it will be I into R. So it is basically V0 minus I is 1, resistance is 3. So basically it is V0 minus 3. That is the potential at this point. Similarly, you can find out what is the potential at this point, because here also I know the current is going to be 1 ampere. This point SS potential will be, if you start from here, it was V0 volts. Here I go in the direction of current, so it will be minus IR. So it will be V0 minus current into resistance. So it will be V0 minus 7. As per the question, we have to find VR minus VS. So VR minus VS. So what is it going to be? VR is nothing but V0 minus 3. VS is going to be V0 minus 7. V0 cancels. So what am I left with? What am I left with, guys? This is minus 3 plus 7, which is 4 volts. 4 volts is the answer. Just check it out. Yes, this is Kirchhoff's law. This is also Kirchhoff's law. Exactly. Ravi Kumar, I have made a micro course on HC Verma solutions. So if you're a part of the Vedantu Pro subscription, be it 11th, be it 12th, or be it dropper, you have complete access to my micro courses, which is HC Verma solutions, Erode book problem solving, my question bank problem solving, derivation micro course. All these courses are freely available to all the students who are a part of the Pro subscription. That's the beauty of it. Yes. So I've solved HC Verma as well. All right. So moving on to the next one coming up on your screen. Two cells, same EMF, different internal resistance, R1 and R2, are in series to an external resistance that are for which the voltage drop in the first cell will be 0. Beautiful question. Sir, should I refer to Deepthi material for physics and chemistry? Alina, I doubt, bacha. Please don't do that. Okay, I have not heard of so much about that book. Okay, so imagine there is a battery, internal resistance, another battery, internal resistance. This is E1, this is R1, this is E2, this is R2. This is connected to some external resistance like this. As per the given information, in this particular battery, you want the voltage drop across the ends to be 0. How do I do that? So let's say I call this as V1 to be 0. V1 is, think about it this way guys, if there is current flowing in the circuit like this, E is forward voltage, there is a drop here of IR. So the voltage drop across the terminals will be E minus IR. Na? E minus IR. Just check this out. Does it make sense? Gokul Logical YT, if you are a part of VPro, na, there is an option, enroll more courses in the Vedantu dashboard. So just click on it and you can just search for the courses and you will be able to enroll. Is IP weightage added to JEE? No, it is not added, Indira. Okay. Alright, so Muzakir Edits, I have made a video on Eamcet strategy. Just search for it on the channel. I mentioned all the books for Eamcet for all the 3 subjects. So E minus IR, I hope everybody agrees with this. So what is the value of I, you might say? What is the value of I? Current, you can find it out easily. Because I know current will be the total voltage E1 plus E2. Alright, E1 plus E2, and both of them are having the same EMF by R plus R1 plus R2. So it will be basically 2E divided by R plus R1 plus R2. And according to the question, this voltage is supposed to be 0. So therefore, E1 minus IR1 is 0. Therefore, E1 is IR1. But I just saw it over here. This EMF is just E. Both the EMFs are same. Current from there is 2E divided by R plus R1 plus R2, and there is R1 here. E and E gets cancelled. Shift these people here. So R plus R1 plus R2 is 2 times R1. Next step, you can take R1 over there and R2 over there. So R will be 2R1 minus R2. So this will be R1 minus R2 is basically capital R. That is what it is. Exactly, option C. Perfect. JEE PYQs? Yes, Ravi. In a bit. As soon as I'm just waiting for the board dates to be announced, that's when most of the students will start preparing for the final lab. So I'm just doing some problem solving sessions, some trick sessions for all of you. Like this week or next week, I'm planning for a circuits problem solving tips and tricks. When there is a complex circuit, how do you find the equivalent? So I'm doing those kind of sessions, which will slowly add 4 marks into your kitty. So there are many things you need to do, just not mock test. You have to attend so many sessions. Like if I do a problem solving sessions on FBD, you attend that. You will get confidence. If I do a problem solving session on circuits, attend that. If I do a problem solving session, which I did last week on ray optics, attend that. Slowly you will get confidence. And that's when it makes more sense to do mock tests and PYQs. All right. Shall we move ahead to the next one? Okay. Yes, Ravi Kumar. Yep. Yeah, sure. Which group is best? Everything is best, but these days obviously computer science, electronics, data science, artificial intelligence, machine learning, IT, right, and electrical engineering, all these are the most preferred branches. Okay, so the weightage, Muzakir, I have made a video again. I think you have not watched that. Please watch that video. Weightage of the chapters. I have also given the strategy. I have also given the books. I have also given the method by which you should prepare for Eamcet exam. Just search on this channel, Eamcet strategy, Shreyas Sir. Just search for it. Next up is Wheatstone's network. Wheatstone's network, standard network. If you have multiple resistors arranged like this, and this resistance by this resistance, and this resistance by this resistance are equal, then no current will flow here. So basically, in this particular situation, if R1 by R2 equals R4 by R3, then R5 is completely useless. It's completely useless. You can completely get rid of that resistance. So then R1 and R2 will be in series. R1 and R2 will be in series. You can see that. And even R4 and R3 will be in series, and their combination will be in parallel. These two resistances will be in parallel. So that's how you can simplify the circuits. Okay. Now, next up is the application of the Wheatstone's bridge, which is called as a meter bridge to measure unknown resistance. Is a meter bridge to measure unknown resistance. Observe. Here, just like in the Wheatstone's bridge, you had two resistors here, and a resistor in between, which becomes useless under the balancing condition. Here also, what you have is one resistance here, one standard resistance or one unknown resistance on the other side. You can see one after the other, there are two resistances, and there is a wire. One part has some resistance, from this point to this point has some other resistance, and you can see there is a galvanometer wire connecting this point and this point. That's exactly this wire. So wherever the galvanometer connects, that divides this wire into two resistances proportional to the length. If point B is more towards this side, this resistance is smaller, this resistance is huge. So this will become smaller, this will become huge. If you move point B here, then this resistance will become huge, this will become small. That means this will become large, this will become small. So you can change the ratio of R by X. You can change the ratio of R by X over here, and R by X will be this by this resistance, or this by this resistance will be this by this resistance. So that's why you get this particular formula. So any unknown resistance can be found by measuring this length, which is L. The remaining length will be 100 minus L, and known resistance is, let's say, R. The unknown resistance will be given by this particular formula. Depends on how you are going to measure it, right? So the length and all. So here this is L, this is 100 minus L. This is known resistance, so R by X. So if X is here, then it will be X by R. So accordingly vary it. If X is here, then X by R will be L by 100 minus L. If X is there, R is here, then R by X will be L by 100 minus L. That's how it works. Is this understood, everyone? It's just the ratio. This by this, this by this. If they are equal, then the circuit is balanced. This galvanometer is useless. No current will flow through it. The current flowing through the galvanometer will be zero. This is Vishu for JEE and Eamcet, not for CBSE. Okay, I hope this is fine. Great. Now you also can combine multiple cells together. If you have cells in series, just simply add, just like you add resistors, E1 plus E2 plus E3 plus E4. All these cells can be written down as one single cell with one single equivalent. The internal resistances are R1, R2, R3. All these cells equivalent internal resistance will be also R1 plus R2 plus R3 plus R4. Very simple. So whenever cells are in series, just treat them like in series resistors. As simple as that. I hope you guys can see it. Great. What if they are in parallel? If they are in parallel, treat it like parallel. What do you do when resistors are in parallel? Use this formula, right? Imagine one cell here, one cell here, one cell here. All these cells you want to combine it into one single cell. If you combine it into one single cell, their equivalent internal resistance will be 1 by R1 plus 1 by R2 plus 1 by Rn. But understand this. When you find out equivalent EMF, then use this formula. E1 by R1 plus E2 by R2 plus ... En by Rn. And 1 by R1 plus 1 by R2 ... 1 by Rn. So there is a small change when it is equivalent EMF for circuits in parallel, for batteries in parallel. It's very simple. E1 by R1 plus E2 by R2 plus E3 by R3 like that on the top, and in the bottom 1 by R1 plus 1 by R2 plus 1 by R3 at the denominator side. That's all. I hope this is clear. I hope this is clear. Yes. Okay, shall we do the problems now? Here comes the first problem. In the meter bridge experiment, the ratio of the left gap to the right gap resistance is 2:3. The balancing point on the left side is how much? So there is a resistor here, there is a resistor here. Think of this like the potentiometer wire. This is that potentiometer wire, and via that galvanometer you are connecting it here. This is L, this is 100 minus L, this is 2:3 ratio. This could be connected to your battery or whatever. Question is, what is the value of L? Come on, do this. Gaurav, because I don't remember, bacha, because I think last year we did not have these forced oscillation. It was, in the deleted portions and all of that, Gaurav. And they generally don't ask forced and damped oscillations in JEE mains. So that's the reason. So there is no other reason for not doing it. Okay, if you want, you can watch my AI live classes. I have done it in the Vedantu Pro subscription. So if you are a part of it, I have already done it there. Okay, so cool. So let's see how do we do this problem. First of all, this resistance by this resistance, 2 by 3 will be this by this. That means it will be L by 100 minus L. So cross multiply. So 200 minus 2L will be 3L. So 200 will be 2L plus 3L, which is 5L. So L will be 200 by 5, which means it will be 40. Just check if it is 40. Yes, Sripriya. Yes, it is 40 meters. That's right. Perfecto. Moving on to the next one. When a battery is connected across the resistor of 16 ohms, voltage across the resistor is 12. Battery is now connected across 10 ohms. The voltage is 11. What do you think is the internal resistance? This was asked as a PYQ. Come on, let's see how you can do this. Come on, my warriors, figure this out. Try to draw the circuit. Then you will understand how the problem is solved. When a battery is connected across this resistance, the voltage is 12. When the battery is connected across different resistance, the voltage is different. So see how it looks. This is the battery, this is the internal resistance, this is the external resistance, this is small r, this is E, this is capital R, this is the current flowing through it. The voltage across the resistor, meaning this one, this voltage will be current flowing through it into its resistance. Current, I know, is the total EMF by the total resistance, which is R plus R. And this R will stay as it is. So I got a generic formula. I will use this for the two different scenarios. The first scenario says when the external resistance is 16, the voltage is 12. So 12 volts when this value of R is 16. So 16 plus, small r. 16 plus small r. And in the second case, the voltage is 11 when the resistance is 10. When the resistance is 10. So 10 plus small r. Obviously, you're going to divide this. Just divide these two guys, see what will happen. So when you divide, it will become 12 by 11 is equal to 16 by 10. And downstairs you have 16 plus r. And upstairs you have 10 plus r. Just cross multiply all of these things. So what will you get? You will get 120 into 16 plus r is equal to 16 into 11. 16 into 11 into what is it? 10 plus r. You can simplify this a little bit and you can solve this and see what is the value of r that you get. Vishnu saying option C. Vishnu saying option C. Sir, 1 hour video is sufficient for single chapter in Eamcet? Yes, Vikram. If you want 25% marks or 10% marks, it is more than enough. If you want little bit more marks, then it is not enough. So in 1 hour video also, you will get that much knowledge only. So that's why you have to watch detailed classes. How much ever effort you put, that much result also you will get. So if you want to put less effort, definitely you will get less outcome. Okay. So answer comes out to be 20 by 7. 20 by 7. No, it is not C. It is option B. Just check it out. It is 20 by 7. So if some teacher or some channel has told you, watch 1 hour classes, your Eamcet will be done within 40 hours or 50 hours, watch all the classes, that's it. You will get really high marks, then sorry, they are fooling you. Okay, chalo, let's move to the next one. So a teacher asked a student to connect n cells, each of EMF E, in series to get total EMF NE. While connecting, by mistake, that student reversed the polarity of n number of cells. So what is the resultant EMF? Beautiful question. So let's try this out. Now, you have so many batteries like this, but after a point, some of the batteries are connected in the wrong way. So like this. So there are n such batteries, small n such batteries which are connected in the wrong way. Total number of batteries is n, capital N. So here these batteries will be n minus n. Because of these batteries, the EMF this way will be n minus n into E. Because of these batteries, the EMF will be like this, which will be small n into E. So hence, when I combine both of them together, the net EMF will be n minus n into E minus NE. So that will be n E minus small ne minus small ne. So you can see it is capital N minus 2 small n, capital E is common outside. So n minus 2n, which is option C, of course. I hope this is clear. Okay, understood? Clearo? Amazing. Let's move on. Vikram, can you please suggest me a playlist? Which playlist you want, bacha? Acha, the playlist. Okay. Watch the Nurture and the Pathfinder playlist, which I just showed some time back. Just watch this playlist here. This is the playlist. It's there right over here. 12th playlist, 11th playlist, it's all there. So watch these playlists, okay? That will help you. All right, fine. Moving on to the next one coming up on your screen. Okay, so we have come to the last part. Okay, so from this chapter, expect at least one question. There are papers where there were 2 questions also. So this is a very important chapter. The concept of current electricity can come in 2 questions at least, or at max, I can say. Minimum 1 question guarantee. You can think of it. Current electricity means motion of what? Charges, right? Electrons, obviously. So now for ammeter and then voltmeter and then potentiometer. So I have conducted a beautiful class only on these devices because they require a lot of detail. But few things which I would like to ask you. When you have an ammeter, is the resistance of the ammeter very high or very low? I want to conduct a rapid fire with you guys. Is resistance of an ammeter very large or very low? Ammeter is usually connected in series, na? It's connected in series. So if you have a very large resistance, it will block the current. Obviously, it will have very low resistance. How do you make the resistance very low? Very simple. This galvanometer which is there, you make the resistance lower by connecting a resistor in parallel. What is that parallel called? It is called shunt resistance. What is it called? Shunt resistance. So it will make the effective resistance very, very less. So ammeter is connected in series. As a whole, it has very low resistance, but inside the ammeter, there is a parallel resistance to the galvanometer. Keep this in mind. Clear? Understood? Very good. Now, whatever maximum current you can measure, this is I max. This is the max current that you can measure using the ammeter. Out of that current, only a small current Ig will go through it, and the remaining current I max minus Ig goes through the shunt resistance. Where does it go from? The shunt resistance. Do you see galvanometer is in parallel with the shunt resistance? Whenever two things are in parallel, what is same? Voltage. So potential difference is same. Potential difference is same, correct? So that means current into resistance is basically same. So here the current is Ig, the resistance is Rg. Here the current is I max minus Ig, resistance is Rs. That's it, that's your equation. Will you by heart this equation? Please don't. Please don't. Okay? Balu, don't spam. If you spam like this, not good. And I think you are just joining in late and just saying, sir, I want more problems. Have you seen what I have done before? No, right? So please first watch the lecture properly and then comment. Don't just come and spam, sir, we want problems, we want problems. What is the use of that? Okay? So understand that whenever you keep a resistor in parallel, the voltage will be same. So current IR will be same. So you don't even have to buy it. You just have to think, whatever current comes, a part of it goes here, the remaining goes here, like a bypass. Like a bypass road, it will go over here. So I into R will be this I into this resistance. As simple as that. Okay. Vishu, this is not a CBSE channel, bacha. We are mainly into engineering entrance examinations, not predominantly for CBSE. So, but when the time comes for the board examinations, like you have seen before also, we conduct CBSE oriented classes, but that is only during the exam time. Otherwise, we are purely focused towards engineering entrance, because through boards, it's just eligibility, but you do not get a college. So for getting colleges, you need to focus on the exams like BTech or JEE Mains or IIT JEE or UG or VIT or SRM or Eamcet. So that's the reason why we focus on these exams. Okay, fine, bacha. Oh, sorry. Oh, you are telling somebody else. Oh, your name is Sonali. Okay, Sonali. Okay. Looks like you are in somebody else's account. All right. I hope, Sonali, that is clear. But you can learn a lot through the JEE classes also. Right? How to get more motivation, Muzakir? Watch classes, watch teachers solve, see how they are solving. If I can make effort, why you can't? My job is done now. Like I have studied, my job is done. Still I come over here. I study and come. I see, search problems. What is the use for me? Not just to become the best teacher, but I love the subject. I enjoy teaching and I feel that you guys should do well. So if the teacher can be motivated, if the teacher is making that hard work, what is your reason to sit and chill? You have to make a life ahead of you. You have to work, you have to earn, you have to support your family, you have to grow, you have to become successful. So if you're going to stay like that, it's not going to happen, right? All right, great. For learning static electricity, so here only Heart Hacker YT, it's just right over here. Just here. Just go to Pathfinder, click on this playlist. It's there, electrostatics, static electricity is there right over there. Next concept, voltmeter. Voltmeter has very large or very low resistance. Voltmeter has very large resistance. How is voltmeter connected? Parallel. How do you make the voltage, how do you make the resistance very large? Connecting a resistor in series with it. So the galvanometer is connected with the external resistance or with the resistance in series to make the resistance large. So as a whole, the voltmeter has very large resistance. So it is connected in parallel to the circuit, right? Okay. Lastly, you have potentiometer formulas. I would suggest please watch in potentiometers. If you go to this playlist, like somebody was asking where is electrostatics, you can see electrostatic lectures are here. So watch this lecture in particular, guys. This is very important lecture. Where did it go? Yes, current electricity, all about potentiometer. It's 1 hour 15 minutes just on potentiometer. All kinds of problems are done over here. I would advise you to learn potentiometer properly over here in case you do not have good concepts. But quickly, let me revise. In potentiometer, first important thing is you have the main circuit where there is a wire which has some resistance. When current flows through it, there is a drop of the voltage. That voltage dropped per unit length. Voltage dropped per unit length is called the potential gradient. Rate of change of voltage on that wire. How many volts is dropping per meter? That's the first thing which you should learn in potentiometer. Next thing you should learn is application of potentiometer. Application of potentiometer to find the potential difference. This is like the primary circuit. This is your circuit in which you want to measure the potential difference. You move the galvanometer till you find the balancing length, and the moment you find the balancing length, the voltage difference or the voltage in this circuit will be gradient into the length, balancing length, which is the null point length. So X stands for your gradient. Look at this. X is your gradient. So X into L. L is the length at which you want to, you are getting null deflection. That's when you can measure the voltage in this circuit using this primary circuit. That's the first application. Second application is to compare the EMFs. Two cells are there, E1 and E2. You first connect this cell, find the balancing length L1. Then connect the other cell E2, find the balancing length L2. E1 by E2 is L1 by L2. That's the second application of potentiometer. Third application is when you want to measure the internal resistance. So you take the potentiometer, connect it to a battery, see where the balancing length comes, note it down as L1. Then again put another resistance in parallel to the battery and then see what is the new balancing length. The balancing length is L2. L1 and L2 will be different. The internal resistance will be L1 minus L2, or you can just call it like this. You can just write it down like this. Old length by that new length minus 1 into that resistance which you have used over here in parallel. That gives you the internal resistance. Internal resistance of the cell. These are the three major applications which you should know. Let's do some questions so that you get a hang of it. Come on, let's do this. Vikram, I think I just suggested it. Very good, Ravi, you have watched it. Awesome. Awesome. Why is AC, Sonal is asking, why is AC connected in series or voltmeter in parallel? So Vishu, why is it done like that? Very good. So let me tell you, simple fact. Like I told you before also, an ammeter has low resistance. An ammeter has low resistance. It measures the current flowing through it. So that's why it should have low resistance. If it has high resistance, it will block the current. So that's the reason why ammeter is connected in series, because you want to measure the current flowing through it. So whatever current flows through it, you will measure it. If imagine ammeter is connected in parallel, then some current will go here, some current will go here. You will be measuring incorrect reading. So this is wrong way of connecting ammeter. But in case of voltmeter, you will have a device. You will have a device and you will be asked to measure voltage difference across it. How do you measure across it? By keeping a voltmeter connecting these 2 points, the terminals of it. So you do not want the voltmeter to be of very low resistance, else all the current will go through the voltmeter. So that's why it has high resistance, else all the current will go through the voltmeter, the device will stop working. So that's the reason for it. Is that understood? Video on entrance examination date for registration. Sonali, I have already made that. Please check. Okay, I have made that. Okay. Is it time to get subscription of Vedantu app for solutions of HC Verma? Yes, Ravi, you can do that because you will get access to my other courses also. Now over here, what happens is, neglecting the internal resistance of the battery, find the value of R. It is given that a voltmeter is connected. So you can think of it like this, of resistance R. and the voltage measured is how much? It's clearly mentioned, 100 by 3 volts. 100 by 3 volts. Now think logically, guys. Use Kirchhoff's voltage law. If across this it is 100 volts across this, and out of that this much has 100 by 3, then logically speaking, how much drop will be there over here? Quickly answer in the chat box. If the total battery supplies 100 volts, out of 100 by 3 is dropped here. How much will be dropped here? Obviously 100 minus 100 by 3, which is nothing but 200 by 3 volts, isn't it? 100 minus 100 by 3, is it clear? Very good. Now, isn't this guy and this guy as a whole, so if you treat this like a single circuit, so this is basically your battery, there is some resistor here, there is some resistor here, just consider it as an equivalent. So this is 50 ohms, this is your equivalent. Won't these two have the same current? Won't this current be same through both of them? And what is current? Current is voltage by resistance, right? Voltage by resistance, right? So how about this? Current is voltage by resistance. Voltage is 200 by 3 by resistance, which is 50, right? That is basically your current. It is also equal to voltage by this guy's resistance. Voltage is 100 by 3. Across this, it was 200 by 3. Across this, it is 100 by 3 by that resistance. Resistances are equivalent. Solve this, see what you get. Solve this, see what you get. 3 will cancel. 3 will cancel. This 0, this 0, this 0, this 0 will cancel. So I can see R equivalent to be 50 by 2, which is 25 ohms. This and this together gives you 25 ohms. So think about it this way. 50 ohms parallel with R ohms gives you 25 ohms. So what is this going to be? What is this going to be? 50 ohms with which resistance gives you 25? Directly you can do it. Directly you can do it. What is that value of the resistance? Obviously that will be also 50 ohms. Don't add. 50 and 50 is not 100. 50 and 50 will be half because it's parallel. Be careful. It's parallel, so it becomes half. So hence the unknown resistance should be 50 ohms. Let's check it out. Yes, it is. Is that understood? Clear? Shall we move ahead? All right, moving on to the next one coming up on your screen. Two cells A and B are connected in the secondary circuit of a potentiometer, one at a time. At the balancing lengths are 400 and 440. EMF of A is this much. What is EMF of B? Comparing the cells. Comparing the cells. Comparing the cells. How do you compare the cells? E1 by E2 is L1 by L2, correct? E1 by E2 is L1 by L2. What is E1 by E2? E1 is nothing but 1.08. E2, I don't know. L1 by L2. So it's 400 by 440. 0 cancels. So cross multiply. So E2 will be 44 into 1.08 divided by 40, guys. This goes with 4 10 times. This goes with 4 11 times. Multiply this and see what you are getting. I think it will be one of these only. It will be 1 point something. I think it will be 1 point this thing. It can't be 1.08, of course. It will be 1.188. 1.188. Yes, that's it. Wonder knowledge, join in. Watch the remaining class afterwards as a recording. Straightforward, direct application of potentiometer for comparing the cells. Next question. An ideal battery of EMF 2 volts, series resistance R, connected in the primary circuit of a potentiometer. Length 1 meter, resistance 5 meter. The value of R to give voltage difference of 5 millivolts across 10 centimeters of the potentiometer. Beautiful question. Let's try to solve this. Can easily come in Eamcet. Observe. There is this battery. There is some resistance. This is your potentiometer wire. This is your potentiometer wire. According to this, there is some current. Obviously, the battery's voltage is 2 volts. and a series resistance is connected. Series resistances are, potentiometer length is 1 meter and resistance is 5 ohm. This is for 1 meter, resistance is 5 ohm. So the current in the circuit will be voltage by resistance, which is 5 plus R. Now here is the logic. I will find the potential gradient. I'll find the potential gradient because that will give me for what length will I get 5 millivolts across 10 centimeters. So think about it. Potential gradient, which is potential difference per unit length, I can say it is nothing but 5 millivolts for a distance of 10 centimeter. This is what the potential gradient has come out to be. 5 millivolts, that is 5 into 10 to the power minus 3. 10 centimeter is 0.1. So it will be 5 into 10 to the power minus 4 volts per meter. This much volts is dropped per meter. Right, everyone? Correcto? Now, can I not say this same voltage will also be dropped across this entire potentiometer for a distance of 1 meter? The same voltage will be also dropped across these 2 points for a distance of 1 meter. So can I not say it is also equal to voltage drop across that potentiometer wire upon the total length, which is 1 meter? Now what is the voltage across these 2 points? What is the voltage across these 2 points? It is IR. It is IR. I is into resistance. What is current? Current is this value, which is 2 by 5 plus R into the resistance, which is 5. So it will be 10 by 5 plus R. Use that over here. Use that over here. 10 by 5 plus R will be nothing but 5 into 10 to the power minus 4. So 5 goes with 10 2 times. So this will become 2. Okay, I hope this is fine, right? And bring this over here. So 5 plus R into 10 to the oh sorry guys, I think I made a mistake over here while I did this. This was not 10 to the power minus 4. I'm so sorry. This was 10 to the power minus 2. Just realized this is 10 to the power minus 2, and this is also 10 to the power minus 2. So this is also 10 to the power minus 2. Solve this, bring it over here. It will become 200. This will become 5 plus R. So R will become 195 ohms. R will become 195 ohms. Just check this out. Yes, it is 195 ohms. So this is the critical step. Generally, when finding potential gradient is voltage difference per unit length. Whether you take these 2 points and see what is the voltage per unit length, or whether you take these 2 points and see what is the voltage per unit length, it's going to be the same. So when I took 10 centimeters as per the question, the voltage drop should be 5 millivolts. But when I take 1 meter, the voltage drop should be current flowing through it. Obviously some current is going into the resistance. IR is the voltage drop. Current is this much. Resistance is 5 ohm. So this should be, this voltage drop per meter should be equal to the 5 millivolts which is dropped per 10 centimeters. So that's why I equated both of them to solve it further. Okay, clear? I think one of the last few questions. Potentiometer cell experiment, 1.5 volts is connected in the secondary circuit. Balancing length 165 for the wire. Okay, so this happens to be L1. If the resistance 5 is connected in parallel to the cell, then the new balancing length is this much. So this is L2. This is one of the applications of the potentiometer which I just showed you here, which I just showed you over here. When you just connect the battery, the balancing length is L1. When you connect the battery with an external resistance, the new balancing length is L2. Use this formula to find the internal resistance. Where did it go? To find the internal resistance is how much? If the external resistance is 5. So small resistance is capital resistance L1 by L2 minus 1. So this will be 5 into 165 by, how much is this? 150 minus 1. So this will be 5 into 165 minus 150 is nothing but 15 by 150. So this goes with 150 nothing but 3 times. So this will be nothing but half ohm. So half ohm should be the answer. Just check it out. Yes, option D is the correct one. It's a beautiful question, guys, again. So this is based on just potentiometer setup and direct formula. I've kept some homework questions as assignment for you. You will be getting it in the Telegram channel as well. This is the first question. This is your second question. This is your third question. And this is your fourth question. Try to solve this, and if you can solve it and you want to show that yes, you have solved it, please put up the answers in the comment section below. Answers and solutions, everything will be there on the Telegram channel, not anywhere else. How was the session? I hope you guys learned a lot and you understood what and all you have to learn. Hello, Krishnu Raju. Is the weightage of chapter wise same for TS and AP? Almost same. You can think of it, Muzakir. Okay, no problem. I hope you had a great dinner, wonder knowledge, and watch the recorded class later on. The next live is going to be, I think tomorrow or day after tomorrow. All right, that's what it is. PDF Ravi, it will be on the Telegram channel. Okay, so bye bye Sonali, yeah, bye bye Hardini, bye bye Vishu, bye bye Muzakir, Florence, bye bye Heart Hacker, bye bye Kristu, bye bye Ajay. Okay, so many students are asking, is IP marks added in Eamcet? Well, earlier it used to be, now it is not. So this year also I think it will not be added. Okay, so next chapter will be ray optics, and before that I'll be doing advanced session on maybe electromagnetic induction, then problem solving session, circuits of current electricity, then you will have ray optics Eamcet session. All these sessions are lined up in the days ahead. Okay, 7 o'clock is my usual time. Okay, bye bye guys, have a great time, take care, hasta la vista. This was Captain Shreyas and I'm signing off.